Hi, everyone. Thanks for being here. So the title of my presentation is Chocolate Sugarcoating STEM Education. And my goal with this project was really to kind of confront the idea of all of these undergraduates who just don't want to be in the engineering classes. And it was such an interesting experience for me getting into some of these Engineering 101 classes, because I found these students who wanted this as the major. They wanted this to be their career, but they just couldn't bring themselves to have any interest whatsoever in the basic concepts. So I wanted to explore that if we used topical examples like chocolate, something fun, would that be able to educate the students but still be interesting? Or would it just be kind of a throwaway, this is fun, but it's not really worthwhile for learning? So next slide, please. So the specific question I asked here, since I couldn't really ask all about all of material science, I chose to focus on something specifically called the eutectic phase diagram. So this has to do with just understanding this type of graph where you write out what phases of some solids exist, whether it's in a liquid phase or different kinds of metals. And usually people do that with metal examples in material science. They'll have some type of steel and they'll see how it becomes brittle at different compositions. Nobody understands that, though. I just got my PhD. I still don't really know what brittle steel looks like. But chocolate, there exists chocolate milk as a liquid. There exists chocolate ice cream as a solid. There exists chocolate chunk ice cream, where there's so much chocolate that it's come out into chunks. These are things that we all understand. So I wanted to ask the question, is teaching the concept of phase diagrams using this approach of chocolate as an example as effective as the standard material science examples, which are those simple metals like steel? So as learning outcomes, I wanted students to leave the class able to define eutectic points and the phase diagram, and I wanted them to be able to identify specific phases in this standard diagram that wasn't actually at all related to chocolate. So the class that I was able to do this work in was Chocolate, an Introduction to Material Science, which was a 1-credit intersession course I designed a couple years back. We had 20 students. It was a mix of humanities and engineering students, mostly underclassmen. And like I said before, some of them were kind of bribed in because I promised samples. And then what I was really happy about, because of the community of the material science department here, I was able to actually get a control class, which is very difficult. I'm sure we've all found in educational research. How do you actually have a control group? You don't want some students to miss out on learning. And frequently we just don't even have that many students to work with. So I was able to get into a Engineering 101 class where they were supposed to be learning standard phase diagrams, and to control for professor quality of myself, I offered the teacher a couple days off and taught in his place, and I had pre and post tests there compared to the phase diagram test in the chocolate class. And then I later gave the students chocolate cake as a reward for helping me. Next slide. So as I was explaining before, this is what I'm talking about when I say the chocolate phase diagram. In terms of what we're looking at here, on the y-axis you have temperature. So as you get higher, you're increasing the temperature, so solid things melt. So your chocolate ice cream becomes hot chocolate. As you go from left to right, you're changing the percent composition. So when you're all the way to the left, you have 0% chocolate. If you're all the way to the right, it would eventually go up to 100% chocolate. And then in the middle, different kinds of things start to happen, and you're going to end up with different types of solid based on composition. So like I said before, you can imagine this pretty easily. You can imagine vanilla ice cream that has a little bit of chocolate melted in it. You can imagine kind of chocolate chunks if there's extra chocolate. And that's much easier than trying to explain to a student what alpha steel versus beta steel is, because it's just not something you can conceptualize. So next slide, please. So on your right here is the student evaluation form that I designed. So what's shown there, it's no relation to chocolate. This is a very standard diagram you'd find in any beginning material science textbook. And what it's showing, it's called the eutectic points. That's where you kind of have this point coming down and you get a temperature suppression. So when you look at this graph, you want a student to be able to point to all of these different areas, and you want them to identify which kind of metal is there, what temperature melting occurs at, all of these types of questions, which really lend themselves to a test where I wanted to be very objective, because I didn't want my own biases to get in the way here. So with this test, I was able to have very simple, correct answers, because I would ask, what is happening at location number 1? Is it mostly compound A, mostly compound B? So I had students in both the chocolate class and the standard control class do pre and post tests before and after my lesson on this subject. So next slide, please. So here I'm comparing the pre-tests and post-tests of both of our classes. So in red is the average of the pre-test. So the standard Math Sci class, this was a class of primarily sophomore engineers, so it makes sense that they've had a little bit more background, even if they haven't necessarily learned this subject matter. They're used to looking at graphs like this. So their pre-test scores were pretty reasonable, around 6.5. And then post-test, they had a pretty decent increase. They got up to 9.8. For intersession, the pre-test scores were significantly lower, which made sense because we had a lot of students here who were kind of self-proclaimed, oh, I'm not a math person, which is frustrating. But so you can see that they started with a bit of a lower score, but their post-test was almost identical. So the students had identical gains in learning, if not actually more of a gain in the chocolate class, despite it being same professor, same amount of time being spent on the subject matter. Really, it was the same style of classroom entirely. The only difference was that I switched out pictures and a group problem. Instead of a question about magnesium and steel, I made it a question about chocolate chips and ice cream. That was the only difference. So I was really happy that I was able to control all of these other variables and really just make it a question about how is this topical approach impacting the student learning. And I think that, yeah.
Jennifer, sorry, you only have a minute and a half left. I forgot the earlier warning.
Okay, next slide, please. Okay, so then I asked how did their interest in material science and food science change over time. The interesting thing was after the full 1-credit material science course in chocolate, we went from 2 out of 20 students saying that they would likely take further courses in this engineering field to 8 out of 20 saying that they would take further classes in it. And we even had one student who came up and talked to me for a while and ended up switching majors to material science because they were so interested in the topic after it was kind of approached in a food science manner. So that was really exciting. Next slide, please. The project implications. What I was most happy about is that by controlling for all these variables and measuring the real outcome, I feel that it really justifies the use of these topical activities, things that might be considered kind of just a spectacle, something to gain popularity. Sure, it is a spectacle, but that doesn't mean it doesn't work. It actually works just as well, if not better, for teaching than the standard example does. So that's saying that these don't just have to be enrichment programs. They actually can be embedded in the course itself. I've also created a number of resources. I've spread it to a number of different universities, and I really recommend, or everybody can go there. And by all means, ask me questions if you want more resources. This is really fun for outreach activities for middle school, high school, undergraduate courses. Next slide, please.
So I'm sorry, the timer is up, so we were not going to have time for questions, which it's too bad because that was such a really cool talk. But we will try to maybe make some time for questions at the end. I think